Let us discuss the classification of the computer systems. Yes, of course, in your syllabus, as per the syllabus, it is a classification of the digital computer systems, but in broader way. First, we will try to understand how exactly the computer systems are classified. So, any computer system, it will be classified either on one of these bases. One of the first choice or basis is either the size or the functionality or the way they handling the data. First one is on the basis of the size, second one is basis of the functionality, and third one is on the basis of data handling. Based on these three, we will classify the computer systems. The same thing based on the size. If it is a size, then these are the classification. One is microcomputer, mini computer, mainframe, and then the supercomputer. These are the four different types which comes under based on the size, and even we also call it as the capacity with respect to the memory. And next again the third component is there, right. In the previous slide we have discussed based on the data handling. The same concept, we can the data, it's the computers will work based on the data principle, or in the working principle with respect to the handling the data. One is either analog, the computer may be analog computer, or it may be a digital computer, or it may be a combination of both. So, with respect to the data handling, the computers can be classified either the analog computer or a digital computer, or hybrid means it is a combination of both. We will try to discuss one by one. And when it comes to the functionality, yes, the computers can be classified as a server. See, you just keep in mind the functionality. Always when we talk about the functionality, these are the classifications. Either it is a server, or it may be a workstation, or it may be the information appliances. The fourth one is embedded computers. These four are based on the functionality. So, the classification of the computers based on this functionality. As we discussed, it is like digital, analog, or hybrid computers. It is the working principle. We also call it as another broad area is nothing but the data handling is also same, or based on the working principle, how exactly you are classifying the systems based on the working principles also the same types, analog or digital or hybrid. So, these are the three major classifications of the computer systems. Now, with respect to the digital computer systems, classification of the digital computer systems, we will try to understand, as already we have discussed in the previous slides, that is micro, mini, mainframe, and the supercomputers. So, now we will try to, as per this syllabus, so we will try to understand. So, what exactly, how exactly micro and mini, mainframe, supercomputer works, and then also we will try to understand the principle, working principle, and also the functionality point of view, how exactly it works. First, microcomputers, as the name itself says, micro, it is a microcomputer is a very small, and obviously if it is a small, there is no much not much very expensive. We call it as a relatively inexpensive computer with microprocessor as its CPU. That means, so very small microcomputer is a small and it relatively inexpensive. When you talk about the cost aspect, it is very less expensive, and because the microprocessor which we use is as its CPU, it is a part of the CPU. What exactly CPU? Central processing unit, the functionality, everything we will discuss in the coming classes. And also it microcomputers includes the microprocessor, memory, and minimal input output. IO is nothing but input output circuitry mounted on single printed circuit board. This is very important. Why it is very small? Whenever we use the term small, so there is inexpensive. So, see, try to understand small and inexpensive. When it will be a small and when it will be inexpensive, everything will be in just, it should be mounted in single circuit board, right. So, that single circuit board, what are all the different components it consists of? One is microprocessor, as already in the previous point we mentioned, microprocessor as its CPU. The same way it includes microcomputer, it includes microprocessor, memory, it is again very much essential, very much required for the computer to process, because it has to store and retrieve the data, that means it requires the memory. And also minimal input output, whenever the computer want to process something, it requires input, based on that request only it will try to process that, and after processing it will generate the output. So, minimal input output circuitry, that will be mounted on the single, everything will be assembled, everything will be in a single circuit board. So, this is the reason, obviously microcomputers are small and also very less expensive. Now, so when it comes to the previous to these computers, before microcomputers there was a mainframes and mini computers, and also there were supercomputers. All these, whether it may be a mainframe and even mini computers, were comparatively larger. When you compare these three, which one? Microcomputer, and another one is mainframes, and then mini computer. When you compare these three types, so this one is smaller compared to mainframes and then the mini computers. Those were larger and it is hard to maintain, because since with respect to the cost, or maybe with respect to the processing of data may not be, when it comes to the individual, maybe yes, may not be having so much of data, may not be required so much of the system configuration for me. Obviously, when we mainframe and many computers have huge with respect to the configuration, obviously it will be more expensive. So, in that manner, so these mainframes and mini computers were larger and also very hard to maintain, and also with respect to the cost, it was main and mini computers were little expensive when compared to the micro. And also these microcomputers basically formed the foundation for the present day microcomputers and smart gadgets that we use in day to day life. I think most of us every day we are using these microcomputers in the form of smartwatches or maybe in the form of tabs. So, these these two comes under the microcomputers. So, in general, you just compare the cost of microcomputers with your PCs or with your laptops, right? Obviously, it is very less expensive. So, in that aspect, yes, may not be for individual purpose or individual the work, the day to day activities may be sufficient, your microcomputers are sufficient. So, since it is everything is mounted in a single circuit board, so obviously cost is also very less. So, this is about microcomputers. With respect to see how exactly it has been defined. A microcomputer is a complete computer, small scale designed. The same thing we have already defined in the previous slide, just in a more precise manner. Small scale designed for use by one person at a time. An antiquated term, a microcomputer is now primarily called a PC, or a device based on the single chip microprocessor. Whatever the device which you use with a single chip of microprocessor, so that we call it as microcomputer. Of course, nowadays mini computers will also come, your PCs, laptops will also fall under that, but most of the time microcomputers, when we say, it is a smartwatches or tabs, and nowadays very less configuration PCs also available, even you can put it under microcomputers. Another important classification of this digital computer systems is mini computers. When you compare to the micro, so larger than this mini computers are bit larger when you compare to the micro, and also used it for small scale processing. So, as you compare with the micro, so these mini computers will be used to process the small scale set of data, and these computers came into the market in the mid of 1960s and were sold at much cheaper price than the mainframes. See how micro is cheaper than the mini is cheaper than the mainframe, right. Now, they were actually designed for control, instrumentation, human interaction and communication, switching as a distinct from calculation and record keeping. So, these are the typical use cases for this mini computers. Whatever the mini computers we have, we use to interact with that application, whatever the application you have installed, maybe by human can easily interact with those applications, and even we can control anything. Suppose if we play an audio or a video, we can just play the next video or we can play the next audio. So, everything easily we can control, and even we can just communication will also happen between the device. Yes, I want to communicate, that means I want to take a print of one document, or I want to scan one document. Obviously, that communication has to be happen between the devices. So, later they become very popular for our personal uses with the different evolution. So, we will try to understand in the 60s to describe the smaller computers that became possible with the use of transistors and core memory technologies. In the mini computers during the 1960s, this is how it was built with the help of transistors and core memory technologies. These mini computers was built. So, what exactly they usually took up 1 or a few inch rack cabinets, that is how it was built, compared with the large mainframes that could fill a room, because see mainframes typically it occupies more space when it compared with that. So, it will be few inch rack cabinets. So, that is the reason the term mini. So, because it will not occupy so much of space. So, that is the reason they use the term called mini computers. So, again your PCs, personal laptops, everything comes under this mini computers. This is another classification of the computer system. So, this is a same explanation, mini computer that was smaller, less expensive and less powerful than the mainframe. See, it is just going layer by layer, one layer. So, microcomputer is less expensive than the mini computer, and even now we will go with one more layer up. So, mini computer that is smaller than the mainframe, and also with respect to the cost, yes, it is little bit less expensive than the mainframe. Obviously, when it is less, maybe with respect to the configuration also it is less powerful than the mainframe, and even the if you take into the supercomputer as a consideration, even less powerful than these two, but more expensive and more powerful than the personal computer. That is nothing but your microcomputers. When you compare to the micros, another side, when you compare to the microcomputer, it is much improved or powerful version of, or powerful than that. But when you compare to the mainframe as well as a supercomputer, it will be less powerful and even the less expensive. Many computers were used for the scientific and engineering computations and your small business transactions processing, small file handling and database management. Typically, our applications, database applications and even small business applications, and another small set of scientific and engineering applications is to deal with this kind of application. These many computers are more than enough. So, these are the typical examples for mini computer. IBM's Honeywell, some of the versions mini computer can support multi users at a time, or so microcomputers it is exactly 1:1 at a time, only one user can use it, but these mini computers can support multi users at a time, or you can say that mini computer is a multi processing system. That one was a single processing, it is a multi, because at the same time multi user can use, or maybe they can use it multiple users can use at a time. So, that it is a multi-processing system. This about mini computers. Now, we will move on to the mainframe computers. So, now we have two ends, two sides, one is other side is micro, another one is mini, another side is it is a supercomputer. Now, we will try to, so commonly used by the big organization for what? Bulk data. See, even many computers also used for processing the data, but we are talking about the bulk data, that means huge data. So, obviously, the organizations, bigger organizations have a huge data to process. So, such organizations to process that bulk data, maybe what kind of bulk data they may have, yes, whether it may be a statistics or it may be a census data processing, assume. So, now I want to just process the census data of Karnataka or maybe India, right. You just see how much data it has. So, with respect to that and even the transaction processing. So, whatever the transactions has been done from last 1 year or last 1 month, right. So, you think about that the data, how big it is, how huge it is. To process all such data, your mini computers or your personal computers may not be sufficient, right. So, the transaction processing of this big organizations and also widely used as these servers, as these systems has a higher processing capability when you compare to the other classes of computers. When you compare these mainframe with the mini and micro, these mainframe computers has higher processing ability. In what way it is higher processing? With respect to the huge data, the size or the volume of the data. It's these mainframe computers are capable to process such huge data, the form of either whether examples of huge data, whether it may be a statistics or it may be a census data or it may be a transactional processing. So, such kind of data whenever we need to process, so obviously we need to go with this mainframe computers. So, and most of these mainframe architectures were established, again even this is also as similar to mini, it is also established in 1916s. The research and development worked continuously over the years, and mainframes of today are more better than the earlier ones. When you compare now, whatever the mainframe systems, whatever we have now, and you need to compare with the older systems, obviously there are a lot of advancement has been happened, and now with respect to the size or the capacity or the efficiency, everything is improved. Earlier it was a big, it requires huge space to keep mainframe computers. Now, no, not even, it's also like similar to your with respect to is as simple as your mini computers. So, that much of advancement has been happened from last so many decades, and now even with respect to the size, the capacity and efficiency also it has been improved a lot. So, example for this mainframe computers, IBM Z series and even the system Z9 and the system Z10 servers. These are the some of the typical systems in this mainframe computers. So, a mainframe computer, see, look at the the first mainframe was, it was developed in 1930 by Howard Aiken, who was the Harvard researcher. See, look at the size of the mainframe computer, and now see the mainframe is a computer formally called mainframe or a big iron is a computer used primarily by large organization for critical applications. As we discussed, it is a huge data processing for tasks such as census, industry and consumer statistics, ERP applications, that is nothing but enterprise resource planning, large scale transaction processing. These are the some of the typical applications where we use mainframes, mainframe computers. Now, another important component with respect to the classification of the digital computer system is supercomputers. So, the name itself super. Super means it's a super fast, right. So, the computers are the most high performing system when you compare all these three like micro, mini or mainframe. These are super speed or high performing systems. So, maybe it is not really required in all the places, but where exactly we require these computers, wherever super basically first we will try to understand supercomputer is a computer with high level of performance when you compare to all those previous classification of the computers. The actual performance of the supercomputer is measured in PLOPs instead of MIPS. What exactly the PLOPs? We will try to understand this PLOPs and this MIPS. Basically, PLOPs and FLOPS and MIPS. Basically, these are the units of measures for the numerical computing performance of the computer. Numerical performance, or we call it as numerical computing performance, right. So, by using FLOPS or MIPS, these are the measures. By using these two, we will measure the numerical competency of the computer. Then what exactly the FLOPS? It is nothing but the floating, see FL means what? Floating point operations. What is that? Floating point operations. So, basically these floating point operations used in the field of scientific computational research. See, name itself floating. Obviously, whenever we deal with the scientific computational research applications, obviously we need a lot of floating values. So, there we use this floating point operation systems. Another one is MIPS. Actually, this we call it as a measures integer performance of computer. We use measure integer performance system, MIPS. It is an integer, I as name indicates integer, there F it is a floating, that is a easy to remember, right. So, we also call it as millions instructions per second, it will be in the form of integers, right. So, basically these are the two measurement units to measure the performance of the supercomputers. All of these supercomputers, maybe whatever the fastest supercomputers it's there in the world, it's all based on the Linux operating system, right. And also supercomputers actually where exactly or which are the in which applications or where exactly we use these supercomputers, basically in the field of computation, and also used intensive computations, very intensive computations are there in the field of quantum mechanics, or maybe a weather forecasting, or maybe a climate research, or oil and gas exploration, molecular modeling, physical simulations. Wherever these kind of intensive computation tasks are there, in all those areas we use these supercomputers, right. It is very much essential, these supercomputers are very much essential in the field of crypt analysis. So, examples for these supercomputers, Param and Jaguar and Roadrunner. These are some typical supercomputers which we can see. The same invented by Seymour Cray, when it was invented 1951. A supercomputer is a computer with a high level performance as compared to the general purpose computer. The performance of the supercomputer is commonly measured in the C. That is what PLOPs we have discussed, right. So, that is PLOPs, floating point operation per second instead of MIPS. So, earlier supercomputers are always trying to measure in the units of flops instead of MIPS, millions instructions per second. So, some of the uses and purposes, supercomputers are used, already we have discussed, intensive, wherever we have intensive computations are there, in all the areas we have used these supercomputers. So, this is one of the supercomputer. It was the first supercomputer, Param, assembled indigenously, was installed in IIT, followed by the Param Shakti, Param Brahma, Param Yukti, Param Sanghank at IIT Kharagpur. These are the some typical some of the supercomputers. And as we have discussed, another principle, another classification base is working principle is nothing but the it's a way of way to process the data. So, one is analog, another one is digital computer. Analog, as the name itself says, right, analog computer. So, basically where the computer, there is a continuously changeable aspects. Most of the electronic or electrical or mechanical things, what we can say, the things are it's a kind of variable by nature, that means keep on changing. So, such kind of systems we use this analog computers. So, analog computer or analog is a type of a computer that uses a continuous variation. See, continuous variation, what do you mean by variation? It is a change, it is a nature of variable itself is a change, right. So, that means the wherever we can see the continuous variation aspect with respect to the, either it may be a physical phenomena, example such as electrical or mechanical or hydraulic quantities. So, everywhere we can see this analog signals, it is a continuous change in the input. So, there we can use these analog computers. See some of the analog computers, see if you see the thermometer, whenever most of the time we use the thermometer. So, obviously, it will be, there is a variation, right. So, that kind of thermometer and even the speedometer, obviously speedometer we use we use in our vehicles, that is also a continuous change. And the clock, seismometer, voltmeter, flight simulators, these are all some of the typical examples for this analog. Wherever, it is very important thing we need to remember is, wherever there is a change, there we can use this analog. So, digital, so as the name itself says, the digits, it is like in the form of zeros and ones. Digital computer, any class of device that can be capable to solve the problems by processing the information in the discrete form, that is, sorry, it operates on data including the magnitudes, letters and symbols that are expressed everything in binary codes, that is in the form of zeros and ones. Whatever it is there, it will process that by using zeros and 1, that is in the digital computers. So, typical digital computer systems are any input output equipment, even or main memory is there, the storage unit, control unit and ALU, that is arithmetic logical unit, it performs all your arithmetic and logical operations. So, these are another this is another type of the computer. Hybrid, of course, it is a combination of both. Some of the computers may require both analog as well as digital. So, thus that we call it as hybrid computers, especially see the petrol pump. So, do not only measure the amount of petrol. So, in the most of the petrol bunks we use, right, it is not only the measure the amount of the petrol, but also calculate the value, right. That is a typical example for this hybrid. So, hybrid computer. So, amount how much petrol, how much amount of the petrol, and also it calculates the value for that. Suppose 1 liter, what is the value for that? 1.2 liter, what is the value for it? So, that means it will be in a position to handle both the functions, or it will be capable to do the both the functions. So, gasoline stations, electrocardiogram machine, ultrasound machine, monitoring machine, research and production industries, forensic and defense. So, these are the typical applications where we use the hybrid computers, ECG, right. Most of the cardiogram machines we use both this digital and analog. It shows both in the analog format like this, and also with the same we can see some numbers also, right. So, that way in these healthcare applications, wherever we have machines, health electrocardiogram or electrocardiogram, and even the ultrasound machines. So, other whatever the healthcare related applications devices there, we can use both analog as well as digital computers. So, some of the features. So, hybrid computers have a high level accuracy and which are capable of doing both analog as well as digital, and also widely employed in the sectors such as defense, forensics and research due to its speed and the accuracy, and also it will communicate with the monitor and also control the devices directly. It completes the task very quickly, and they can also effortlessly answer all the difficult equations and also combine the features of both analog and digital, as we discussed. The name hybrid in the beginning itself discussed. These are some of the features. So, next session we will continue with the anatomy of the computer. Thank you.